Hello everyone, once again welcome to our Computer Science 9618 ASNA level lecture series. Our topic for today focuses on some introduction or basic concepts about assembly language programming. Your lecture, once again, Mr. Jun. Alright, let's start with the key discussions for this topic all about assembly language. We are going to show understanding of the relationship between the assembly language program or assembly language here to that of machine code. We are going to describe the different stages of the assembly process for two-pass assembler. I'm going to discuss this in a separate discussion, as this would entail a very good discussion about two-pass assembler or two-pass assembly. This is always included in any examinations, and of course most especially for AS level. We're going to trace a given simple assembly language program, show understanding that the set of instructions are grouped into different instructions, meaning different categories of different assembly language instructions, and then of course show understanding of some addressing modes and understanding and perform binary shifts, in which I already prepared also a different or a separate discussion about binary shifts, or we have that bit manipulation. To start with, let's take a look at machine instructions. One of the reasons why our computers, or it is considered as digital computers, because from the word alone, digital, it actually connotes the zeros and ones, or simply the instructions, the instructions for what we call this one, our machines, or the only thing that is being understood by computers, since it was mentioned that it is a digital computer, are actually in the format of binary. And of course, this is actually being synonymous to what we call the machine code. Machine code, or the binary code, that is the language of our computer. Of course, machine code consists of sequence of instructions, although the representation there is in the form of binary. Let's take note that all instructions contains opcode, and of course, the operational code, and most of the instructions, in assembly language programming, it comes with also what we call the operand, or simply what is the data that is going to be processed by the instruction. So different processors also have different instruction sets associated with them, so that depends on what type of processor that you have. And then of course, the instructions embedded on different processors are also different, meaning it depends on the microprocessor that is going to be used. For example, the microprocessors that we are using in our computers or in our laptops, there are some also microprocessors that are actually being used in embedded systems, so they also have different instructions that are actually being embedded in such microprocessor. So have a look that in assembly language instruction, there should always be an opcode, and at the same time there is an operand. We will look into further wherein there are some opcodes, operational codes, that doesn't require or doesn't have any operands at all. So when we come to the discussion of the different categories of this different assembly language instruction. Now, the first programming language to be developed was, of course, assembly language, and it is closely related to the machine code and uses mnemonics instead of binary. So the assembly language right now, if you can see here, this area here, the LDD total, add 20, and then STO total, this is an example of assembly language program, or simply the syntax or mnemonics. It uses what we call the mnemonics. It's somewhat difficult also to understand, but comparing to the machine code, which is in terms of hexadecimal, and when it is being converted into binary, you cannot totally understand what are the instructions that these binary numbers represents, even in the machine code for the hexadecimal. So the development of this assembly language program might as well will give you an idea how what are the instructions that are actually being executed or when you program using assembly language programming. Usually, most of the time, assembly language programming is used for embedded systems. When you in during my college years or university years, we usually burn, or that's the name that what we call, we burn the program inside the microchip. Usually what we used last time is the famous PIC 16F84. 16F84. It is a programmable interrupt controller. So we do assembly language programming and we download the program on the PIC. And this would serve as the brain of the device or whatever projects, okay, or whatever instructions you place on the programmable interrupt controller, and that's the one that would give the set of instructions to the device that you want to or to function. It depends on what application that you're going to use. Usually we use this one for robotics also. I mean simple robotics. Okay. The next one is a two-pass assembler. As I mentioned, I just want to give a brief discussion of this two-pass assembler. This is actually the main goal of the two-pass assembler is how does the assembly language program, so from the assembly, we have there the assembly language program will be converted into its equivalent machine code. Okay, or simply before the machine code there is what we call an object code. Okay, we will going to discuss this one later on. Machine, or there's also what we call an object code that is being discussed later on. Okay, how the machine or the binary numbers, the representation of the program itself, how are you going to represent the opcodes and the operands in its equivalent machine code. Okay, so from here, two-pass assembler is designed to handle programs written in the style of which contains forward references. So that's we will discuss later on why it is considered as a two-pass assembler. Why not 3? Why not 4? And why not 5? Why not only one-pass assembler? So we're going to discover that one. All right, let's take a look at the structure of an assembly language and machine code. So if you try to take a look here, there's already a discussion of a mnemonic a while ago. It's just a symbolic abbreviation of the operation code. So the opcode that we use here is LDD, that is load direct addressing. So we are just going to continue what is this LDD later on, okay, when we talk about the addressing modes. And then you notice the total here is considered as the operand. Okay, so usually the data possible, the data resides on a memory or an address, and then of course, yeah, that's one good thing in what we call this one in assembly language programming. Usually it doesn't on the data or the opcodes, the data or the operands doesn't only resides on on the memory, but it also resides in considered as a register. Okay, in higher assembly language programming, of course, I've learned this one when I was in the college, but yeah, it's also very difficult to understand and to program, especially that there are numerous of instructions in the form of mnemonics. So in mnemonics, or it's just a symbolic abbreviation, and it's not easy to memorize. Okay, but comparing to that of the machine code, which is in terms of hexadecimal, okay, this one is actually readable as compared to this machine code in hexadecimal. So take a look at the representation. If I'm going to take a look at this one, 0140. So it was mentioned there that 01 contains the opcode. So the opcode was already in the form of an hexadecimal format. The operand is also 40. It's also in the form of hexadecimal format. So we cannot understand, you cannot actually identify what is that instructions. That's why they created actually the assembly language program. So at least in its simplest sense, yeah, in a very simple way, okay, there is actually a simple understanding of what is that instruction. Okay, so with the use of mnemonics. Now I mentioned a while ago what are the addressing modes. Addressing modes are, these are techniques or methods on how are you going to access the different data or the operands, or the operands might reside on a register, or you can actually use what we call a direct value. Okay, so most of the on top of the different addressing modes. Actually, when we discussed this one in assembly language programming concept, I mean, as one subject, when I was in the college, actually we have around seven, almost seven, yeah, seven addressing modes: 1, 2, 3, 4, 5, 6, 7. But in this case, we're just going to discuss about here the four, okay, the four important and most common addressing mode that is being used in our own context for assembly language programming for the A level, AS and A level. So we have what we call immediate. The operand is the value to be used in the instruction. So an example here that was given is sub or subtract. There is a hashtag there which is 48. The presence of the hashtag would mean that is a denary value, or we call it as a decimal value. Okay, denary or decimal value. It's a decimal value. So the value there from the word alone, immediate, the use of the hashtag. Okay, so that's an example. Direct is the operand is the address which holds the value to be used in the instruction. So the value is actually stored in another address, okay, in some memory location. Indirect, the operand is an address that holds the address which has the value to be used in the instruction. So it is from the word indirect, or we call it as register. Okay, the the operand is an address, meaning it is a memory location. Okay, it is a memory location. There are some instances that there is what we call the use of like this. Let's say move. Okay, just to give an example, move AX. So we have the AX register, and then this is in the context of assembly language programming in itself. So usually this is an address, let's say starting at 0 to 100. This means that the 0 to 100 is actually an address, and that address contains the value to be used in the instruction. So that's what we call indirect addressing. For direct is the value is actually stored in the what we call some labels or some variables here, total. But of course, yeah, this total is being stored in a memory location, because whenever you declare or use what we call some variables, it means you are going to segregate a memory, or you're going to allocate the memory for that particular variable. In this case, it's the indirect. Okay, the operand is an address that holds the address which has the value to be used in the instruction. So it's an obvious what you call an obvious what you call this one obvious definition wherein the operand, okay, is an address. So it resides, okay, it resides to another address. And then index is there is some calculations here. You're going to do some calculations with respect to our index register. So there is an addition of an index register, usually in AS level and A level. We call that one as the IX. Okay, so whatever is the address of the next of the address of the where the offset address, and at the same time plus the value of the index register, that is actually the value that you're going to consider. So the operand is an address to which must be added the value currently in the index register to get the address which holds the value to be used in the instruction. So it points to one address, okay, plus the displacement value from the index register. And if you add that one together with the address that is actually being pointed out by the addressing mode, then whatever is the result of the addition, that is actually the operand that you're going to consider for the use, or for the instruction or the operand that's going to be executed. So we're just going to discuss some examples later on when we do the what goes on the program tracing. So it is best described when we are going to implement it using a program tracing. Alright, let's move now to the different categories of assembly language instructions in in some past papers, yeah, there are some discussions or some questions that would ask the students, okay, to identify which of these instructions or what category of the assembly language instructions that this particular operand or instructions belongs. Okay, let's take a look at the different instructions. We have what we call the data movement instructions. So you notice here there is already the LDM, LDD, load the number AC to immediate addressing is used. So this one, LDM is loading a what we call this one, a value, and this is actually considered as an immediate addressing mode. LDD is direct addressing. Your LDI now here is considered as the index addressing, indirect addressing. Okay, indirect. So from here, from our discussion a while ago, indirect. So the operand holds the address to which the value to be used is to which the value to be used in the instruction. So LDX is very obvious. That is now with the use of index register. We call that one as the index addressing mode. Okay. We also have what we call the LDR, load the number into IX, still immediate addressing mode. Okay. Load register. There's also another LDR, but the operand, it only differs on what operand to be used. Move, this is a most common data movement instruction. Store, STO or store, we call it store. Then end, return control to the operating system, is a movement. Okay, and then the different important registers that are going to be used, and some terminologies here. Your ACC means single accumulator or simply the accumulator. IX, index register. B is a binary number, and then AND is a hexadecimal number, and of course the hashtag is a denary number of decimal number. So take note of the different symbols or letters being used to denote whether it is binary, hexadecimal, or denary number. Next one is input and output. There are only two most common instructions for this, in and out. Of course, in, this is simply asking a input from the user. You take note there is no operand, yeah, there are no data that's going to be used here. So because it's just simply out, you display, or you print, or you out, or you output it, should I say. Next, arithmetic instructions, the same. If you notice, still the opcode or the instruction that is being used is it's just the same to the most common English language that we are using for example, the addition, add, subtraction is sub. Your increment means INC. INC means increment. Okay, adding one to the contents of the register, either the accumulator or the IX. The other one is decrement. Take note of the operand. It's a register, meaning to say it's a memory location. Okay, or if it's an address, it actually give the address of that memory. Okay, the actual address. Next, we also have what we call unconditional and conditional jumps. Okay, so you will seldom see this in some of the past papers that we're going to discuss later on. JMP stands for jump to specific address. So there are some instances that the part of the program, after executing one line of the code, what would be the next thing to do? Okay, so if you just jump to an address, or simply jump to a specific address, because the operand here is an address. Okay, JP, jump not equal. This means jump equal if the comparison of the accumulator is equal, and then you just do what we call jump equal. If not equal, JPN. Okay, and then end, of course, end is also considered as unconditional or conditional instruction jump instruction. Okay, but of course the unconditional and conditional, okay, that involves with some of the different criteria or some conditions to be satisfied. Compare instructions, this is usually a tandem, or usually this is in pairing with our jump instructions. Okay, usually jump instructions occur when there is a comparison with the values of the accumulator or not. Okay, compare, CMP. Actually, there are two operands for compare: address, or simply you're going to compare directly to the value. And then CMI here is address to be used in the contents of specific address. Compare the contents of the contents of the given address with the ACC. So comparison that uses indirect addressing, comparing it to the value of the accumulator. Now I want to show also one example of assembly language program with how this program is going to be executed in our microprocessor. This would probably end our discussion of the basic concepts and introductions for assembly language programming. Okay, so we have here a very famous we call a very famous website here. It is simply to illustrate how assembly language program are being executed in the microprocessor. So we have here, there is already a simulation software. The CPU, there is a program counter, instruction register, what will be the value of the address register, accumulator that keeps track of the value, okay, being manipulated, and of course the arithmetic and unit area. Okay, let's take a look at some where's that? Let's say just an additional a very simple program to do an addition. So if you try to take a look here, int inp input, and then SDA store at 99, and then input again, then add, then out, and then halt. So it's just a very simple assembly language instruction. Of course, this is just for us to know how it is being executed in the computer. Now, usually what I use last time when I discuss about assembly language programming is with the use of TASM, Turbo Assembler, and then it was upgraded later on to MASM. So there's a lot. Yeah, MASM is the macro assembler or Microsoft assembler. MASM 32. All right. If I'm going to run the program, okay, you try to, or we just do some stepping on it. Step. Let us submit first, and then step by step. You notice there's already a fetching of the data, goes to the address register. So it requires us to input a number, let's say 7, and then next. Okay, 7 was already inputted. Alright, so yes, 7 was already, okay, and then step again, and it will ask us again to input another number. Okay, it will store in the value 99. Alright, then next. Then it will ask me to input a number 7 again. Press enter. The value will be placed in the accumulator. Notice that the accumulator was loaded with 7, and previously the accumulator has 7 values, so it should return it should output the value 14. So it was fetched there. Then it will process in the arithmetic and logic unit, and then let's do the step again. After processing, then it should place there in the output area there the value 14. Okay, then you notice the output there is 14 already. So it's not easy for the processor to do, but of course with this conversion of assembly language program into its equivalent machine code, yeah, that's a very important feature of an assembly language program. Alright, so that ends our discussion about introduction of basic concepts to assembly language programming. Thank you.